Welcome to a captivating exploration of the hidden chambers and passageways above the King's Chamber in the Great Pyramid of Giza. In this video, we delve into the initial discoveries by Caviglia, followed by the meticulous cleaning efforts by Vyse and later Edgar. These passageways play a crucial role in the pyramid's ventilation system, and Edgar's 1928 endeavor to clear debris was a monumental undertaking. The narrative also sheds light on the challenges faced during the cleaning process, such as using handcrafted scissors and uncovering a massive iron crowbar in Caviglia's pit. The modern exploration by Gantenbrink and his team, utilizing advanced techniques like laser measurements, further contributes to the removal of debris. The video analyzes the layout of the passageways, examining the unfinished blocks within and delving into engineering and design theories, including star alignments and specific geometric relationships. It questions the purpose and complexity of the relieving chambers above the King's Chamber, with some proposing a connection to the symbols of Ramses V on the chamber's equidistant walls. The video also focuses on the construction materials used, granite and limestone, and structural issues reported by Petrie. Finally, the video points out construction lines and marks within the relieving chambers, emphasizing the need for additional data and clear images for future analysis. Join us on this archaeological journey as we uncover the secrets and hidden details of the passageways and chambers within the Great Pyramid of Giza. Unveiling the Enigma, inside the Great Pyramid's hidden chambers and mysterious shafts journey into ancient wonders. In contrast to the shafts in the Queen's Chamber, these particular shafts seem to have been intentionally left open. Colonel Howard Vyse took on the task of clearing away the debris from these shafts. According to Paring's report, Figs. 1 and 2, Plate 3, show the excavation carried out by Mr. Caviglia along the northern air channel. And Fig. 4, Plate IV, is a cross-section of the exit of the same, which, for a distance of 47 feet 6 inches from the exterior, has been forcefully directed downward. When initially discovered, this forced section, along with the entire channel, was filled with desert sand. Colonel Howard Vyse undertook the clearing process, not only for this forced part but also for the southern air channel. As a result of Vyse's efforts, the pyramid's ventilation has been restored. In Paring's Figure 4, we observe what seems to be an excavation carried out by Caviglia. Similar to his previous attempt from the chamber end, this excavation only covers a short distance. Caviglia also made a small excavation from one of the relieving chambers in an effort to intercept the southern shaft. Over time, it appears that the shafts became blocked again, leading to Edgar obtaining permission to clear them in 1928. Edgar recounts, "When I was at the pyramid in 1928, I obtained permission from the Egyptian government to clear the debris from these channels. During his initial visit in 1909, the south air channel of the King's Chamber was open, but the north air channel was completely blocked with stones and hardened dust." Edgar's objective during his 1928 visit was to clear the obstruction from the north channel, which proved to be a challenging task. The south channel had also become blocked with debris over the past 2 decades. To address the issue and prevent future blockages, Edgar directed his workers to construct masonry at the outer ends of the channels. This masonry was designed to prevent dust or stones from being washed into the channels by rain. Despite Edgar's efforts to clear the debris and implement precautions, modern ventilation systems installed with the assistance of Gantenbrink now utilize these shafts. It remains uncertain whether the shafts originally opened through the casing, as the risk of rainwater entering and potentially damaging items in the chamber raises doubts. Edgar acknowledges the success in clearing both shafts but notes that Gantenbrink found the shallower north shaft still required a significant clearing effort, suggesting that complete success in preventing debris may not have been achieved. In the picture featured on Gantenbrink's website, we observe Ulick Cap carefully maneuvering himself into the excavation made by Caviglia in the north shaft. In this additional image, we get a glimpse inside the excavation carried out by Caviglia, a site that they refer to as the Mankiller. Within this excavation, the team discovered a severely corroded 30 kg iron battering ram mounted on wheels. The ownership of this object remains a mystery. Edgar cleared the shaft in 1928. It raises questions about whether he could have utilized it or if it possibly dates back to the time of Howard Vyse. In the process of clearing the north shaft of debris, Gantenbrink describes their approach. "We crafted our own ram, aiming for a more effective tool by sharpening one end of a truck axle and welding a large chisel onto it. Carrying this 40-kilogram contraption to the entrance of the man-killer, we attached a rope to the rear end of our improvised ram. Subsequently, we sent it sliding down the chute. It accelerated for a few seconds before crashing into the plug of debris, achieving the desired effect of breaking up larger stones into smaller pieces, some of which slid down the shaft. However, one attempt was not sufficient. It was only on our third run that we achieved the breakthrough, and hundreds of kilograms of dust and debris, surrounding our axle, poured down the Caviglia tunnel. The interior of the pyramid was enveloped in dust for several hours, but for the first time in at least hundreds of years, the upper northern shaft was clear. Gantenbrink seems to be unaware of the efforts made by Vyse and Edgar, both of whom claim to have cleared the shaft previously. The accompanying image displays Ulick cap within Caviglia's excavation, originating from the antechamber. All the debris from the clearing process would accumulate in this location, with the original shaft situated at the top of the picture. The team implemented a plastic pipe through Caviglia's excavation to prevent further debris from entering and safeguarded the outlet. It would be intriguing to acquire detailed information about the masonry layout in these excavated areas, shedding light on how they addressed the challenges of placing masonry. This was particularly complex, as the masonry was often laid at different angles compared to adjacent sections. For example, the masonry in the shaft and the gallery likely followed distinct inclines. The mentioned excerpt is derived from Gantenbrink's CAD files. Similar to the shafts in the Queen's Chamber, the predominant type of masonry forming the shaft is composed of Type A blocks. The large granite blocks constituting the chamber walls are referred to as Type E, resembling the north shaft block in the Queen's Chamber. Type D blocks appear to be exclusive to this shaft. Block D, along with blocks 3 and 4, deviates to the northwest to circumvent the substantial masonry of the gallery. In the provided view, the joint between the two granite wall blocks is observed along the floor of the shaft. According to Piazzi-Smyth's tables, this wall joint is positioned 103.3 inches from the east wall, equivalent to 5 cubits. 12. Despite the significant damage to the entrance of the southern shaft, the well-preserved floor and joint line of the shaft are still discernible. According to Smyth's tables, this wall joint is approximately 100.1 inches from the east wall, while Aiton and Inglis suggest 100.4 inches in the same table. Interestingly, Meriglio and Rinaldi provide conflicting measurements for the shaft's axis from the east wall, indicating 2.46 meters, 96.9 inches. They stake 2.48 meters to the east side of the shaft, and gives the joint as 2.54 meters or 100 inches. From images, the joint line in the south shaft seems to be not equidistant, with the greater part of the floor west of the joint, possibly to maintain the shaft close to the 5-cubit mark. The better preserved opening on the north wall is reported to be 8.3 inches wide and 5.7 inches tall. In the highlighted portion of the image, attention is drawn to a massive lintel situated above the entrance to the chamber, spanning the height of 2 courses. Smith provides the dimensions of this substantial block as approximately 122.7 inches, 3.12 meters, in width, with a height of about 2.39 meters. According to Meriglio and Rinaldi's TAV7, the lintel is approximately 1.28 meters thick. The block, as visible, spans about 6 cubits in width, potentially designed to extend a cubit over the joint below. Although the overlap built into the east wall is unknown, assuming a cubit overlap, the block could be around 11 cubic meters or over 30 metric tons, although the ceiling beams would likely weigh considerably more. There are inconsistencies in measurements, particularly regarding the size of course blocks and the horizontal length of the north shaft before its upward angle. The block adjacent to the doorway under the lintel is a single block extending to the south wall of the antechamber, measuring approximately 100.8 inches, Petrie, or 2.56 meters. Gantenbrink's CAD drawing suggests a level shaft throughout this distance, indicating a horizontal section of 2.63 meters. However, Meriglio and Rinaldi's TAV7, Fig 1, proposes a different measurement, and this shorter distance is also depicted in Paring's Plate 3 drawing. The accuracy of these measurements remains uncertain, reflecting the broader issue of inconsistencies and conflicting data throughout the pyramid. Gantenbrink notes the presence of unfinished blocks in both shafts. For instance, the longest block discovered in the north shaft, block number 23, measured approximately 4.37 meters in length, with its ceiling being partially unfinished. In Gantenbrink's CAD drawing, the beginning of the south shaft from the king's chamber is visible. Block 5 posed a significant obstacle due to its unfinished state, resulting in a narrow ceiling height of 9–10 centimeters. Gantenbrink expressed his view on this block, stating, "This is an obvious example of inferior workmanship, what we refer to as a Monday morning block." Block number 5 was almost certainly inserted without authorization from the architect or master builder. The discovery of a number of such unfinished blocks in both upper shafts and in the lower southern shaft as well would seem to indicate that the shaft builders made up a separate working group. This group apparently lagged behind at times, pressured by the rapid rate of growth of the pyramid layers and the construction of the chambers. This would also explain the extreme angle fluctuations in the vicinity of the king's chamber. Further up the south shaft, there are two noteworthy features, one of which is a vertical joint. Gantenbrink explained, "Between block number 15 and 16 we discovered a vertical joint. In the shafts, such joints, which have a distinct static function, otherwise occur only proximate to the chambers. It is a complete anomaly to find a vertical joint fully isolated in the nucleus of the pyramid. Since it requires much greater effort to shape and fit the blocks in such an arrangement, we can assume that the builders must have had significant structural justification for going to the trouble of deflecting forces into the horizontal plane." The other intriguing feature is what Gantenbrink refers to as niches in both walls of the shaft at the end of block number 23. The plan view of this area is depicted here. In this image, the laser dots are visible, hitting the niches on the sides of the shaft. Gantenbrink commented on this area on his website, addressing Professor Stadelman's suggestion that these niches might parallel the closure stone, or slab, in the lower southern shaft. Stadelman proposed that the niches could have been part of a former mounting structure for a shaft closure stone. However, Gantenbrink raised several points challenging this hypothesis. 1. The eastern niche forms a groove, while the western niche is a recess, extending to the end of the block. This arrangement would hold a small plugging stone in place on only one side, rendering the groove on the eastern side purposeless. 2. A small plugging stone couldn't have been lowered into the shaft from above as suggested by Professor Stadelman because the shaft in block number 23 is wider than block number 24. Laser measurements conducted in 1992 confirmed this difference, making it impossible for a plugging stone narrow enough to fit the top of the shaft to stay in place. 3. Professor Stadelman's hypothesis raises questions about how a plugging stone embedded 12 meters deep into a shaft measuring only about 20 by 20 centimeters could be later removed without damaging the niches. 4. Even if one assumes that the groove in the recess originally held a stone slab, challenges remain regarding the insertion of such a slab before the corresponding block was set in place, and the difficulty of removing it without damaging the niches. While the possibility remains that a stone slab was planned but never incorporated into the construction, it doesn't precisely parallel the situation in the lower shaft. The upper shaft's ceiling lacks a recess like that in the lower southern shaft at the slab. The upper butt joint of block number 23 is unusual, forming a rectangular concave profile. Additionally, the floor joint aligns with the shaft joints. Stadelman's idea of a door in this location is feasible, but it would likely need to be in place before the next narrower stone was laid. As for the lack of damage to the niches, a thin door could easily fracture, with fragments falling down the shaft, potentially mixing with other debris. A possible niche may have existed in the shallower north shaft, but due to Caviglia's excavation in this area, any niche that might have existed has likely been destroyed. Despite the bends in the shafts, it appears that attempts were made for both sets of shafts, kings and queens, to exit at the same level. While the queen's shafts are symmetrical due to the east-west axis of the chamber, adjustments had to be made in the king's chamber, which is displaced south of this axis. Various suggestions have been made regarding the likely design scheme for these shafts, ranging from no planned scheme to alignments with certain constellations, stars, or geometric relationships to the pyramid structure. In the provided figure 7 by Gantenbrink, He has created his own model based on the available data at that time. It's important to note that during this analysis, the limits of the Queen's northern shaft were unknown, and the hole had not yet been drilled through his door in the Queen's southern shaft. Gantenbrink uses color-coded quantities that seem to occur regularly between specific construction points. One notable observation, as mentioned in Legan's article, is the recurrence of the unit of 121 cubits. This number appears to repeat in the length of the Queen's chamber shafts and might be confirmed by the hieratic found behind Gantenbrink's door. Gantenbrink comments on these construction points, noting that the heights of all construction points are essentially either 1/40th of the basic width of the pyramid, 1/40th of their height, or, in two cases, even 1/40th of both, referring to the construction points of the upper air shafts. He finds it surprising that when considering the base of 440 cubits divided by 40, it produces 11, and the height of 280 cubits divided by 40 produces 7. With two exceptions, all distances of the same length are divisible by 7 or 11 or both. This clear subdivision into 40ths leads Gantenbrink to suspect that the architect of the Cheops pyramid worked on a scale of 1/40 when placing the plan, possibly on papyrus. In Gantenbrink's figure 8, he illustrates some of the height relationships he observed. For example, the height at which the king's shafts would exit is depicted as 22/40ths or 154 cubits above the base. Legan's work also supports that the shafts exit at 154 cubits above the base. If we could lift the top of the pyramid at this point, its base would be 198 cubits. As both exit points are 121 cubits horizontally from the pyramid's base, totaling 440, 121 plus 121 plus 198 equals 440.130. This base of 198 cubits aligns with the height from the granite pavement of the king's chamber to the pyramid's apex, also measuring 198 cubits. The pavement is set at 82 cubits from the base. 82 plus 198 equals 280. The diagonal of a square base of 198 cubits is 280, equal to the height of the pyramid. The chamber floor at 82 cubits aligns with the level of the pyramid, where the base area at this level is half the base area of the pyramid. The diagonal of the pyramid at chamber level is equal to the base of the pyramid, i.e., 440. Gantenbrink's figure 10 illustrates the simple geometrical relationship he perceives. He argues against the Bouval theory that suggests the shafts were aligned with certain stars, asserting that the shafts are clearly designed using whole numbers and follow clear geometrical rules. The alignment with certain stars would be too much of a coincidence given the consistent exit height. The intriguing aspect here is the precise shift of the lower construction point of the shafts from the pyramid axis, amounting to exactly 22 cubits or 2 by 11 cubits. This shift posed significant challenges during the execution of the construction because the exit points needed to be at an equal height. To achieve this, not only did two angles have to be determined, but also the ratio of these two angles to each other and to the axis of the pyramid, ensuring precise structural execution. Figure 10 illustrates the mathematical geometric principle employed to solve this problem. A grid of 11 by 11 cubits was placed above the pyramid, corresponding to a scale of 140 in relation to the pyramid base. Although the actual Cheops grid is rectangular, with a ratio of 7 to 11 cubits, 1/40th of the height to 1/40th of the base, a square grid is used here for clarity in explaining the design process. The right northern shaft is designed in a ratio of 11 to 7 grid points, and the left southern shaft in a square ratio of 7 to 7 grid points. By reversing the ratio from 11 to 7 to 7/11, the counter angle in the diagonal, indicated by a broken line, is obtained, which lies at 90 degrees to the northern shaft. The angle, counter angle, and square counter ratio can be geometrically determined. Considering that the ancient Egyptians had limited drawing aids and could not precisely determine intersections in a grid through drawing alone, mathematical proof of assumed intersecting points was necessary. The Rind papyrus indicates that the ancient Egyptians used fractions in their calculations. It is plausible that this simple mathematical knowledge was applied during the Old Kingdom. Ratios such as those encountered with the shafts can also be expressed as fractions, where the x quantity forms the denominator, and the y quantity forms the numerator. For instance, we say that 11/7 forms the counter angle of 7/11. In Legan's work, He presents a diagram of the shafts, and he also delves into the geometry of the queen's shafts. He explains, "Now turning to the shafts leading from the queen's chamber, it so happens that the northern shaft is directed towards the same geometrical focal point as the northern shaft from the king's chamber, and that the lines of these shafts derive from the same geometrical construction. I have previously noted that if the shafts from the queen's chamber had been completed, they would have opened through the sides of the pyramid at the level of the 90th course, which is 2,711.1 inches or 131.48 cubits above the base according to Petrie's data. This course marks one of the great stages in the core masonry of the pyramid, being noticeably thicker than any of the preceding 44 courses. And it is exactly defined by the center of the square with the side of 99, 198, or 297 cubits, which is already given in Figure 2 by the distance from the apex of the pyramid to the focal point of the shafts. The level for the outlets is therefore constructed as 280 and 297 halves, or 131.5 cubits over the base of the pyramid, giving a profile of 1 rise on 2 and 11/14 base, or 14 rise on 17 bases, with a theoretical angle of 39 inches 28 feet 21 inches. While this angle closely matches the south shaft angle given by Gantenbrink, other suggestions include that the angle is inverse to the casing angle, such that the shafts would form a right angle at the casing, i.e., 1411, which gives an angle of 38.9 feet. Leggen would go on. The level of 131.5 cubits for the outlets of the shafts from the queen's chamber is that at which the diagonals of the cross-section measure exactly 330 cubits or 3/4 of the sides of base. You, dear viewer, can make what they will of the observations by Gantenbrink and Leggen. Though for my own part, I feel that they are commendable solutions worthy of further investigation. Aspects of the geometry also seem to appear in the giant pyramids at Dashur. However, as bad as the data is on the Great Pyramid, matters are so much worse on those giants. The relieving chambers. In the portion of Meriglio and Rinaldi's TAV8, Figure 3, you can observe the somewhat irregular arrangement of the granite ceiling beams that extend over the vacant spaces above the king's chamber. Information regarding these spaces is somewhat limited, with most images focusing on the controversial Khufu hieroglyphs. As mentioned earlier in Part 1, I don't raise concerns about the hieroglyphs or the mason's markings discovered in these chambers, although some researchers suspect significant deception by Howard Vyse. The structure of these spaces is completed with limestone beams, similar to those found in the Queen's Chamber and illustrated in Paring's section. According to Paring, the distance from the King's Chamber floor to the ceiling of Campbell's chamber is 69 feet 3 inches or 21.11 meters, approximately 40 cubits. The design of the relieving chambers above the King's Chamber in the Great Pyramid has raised questions due to its seemingly intricate and heavy structure. The term, relieving chambers, might be a misnomer, as these chambers don't appear to relieve any specific pressure but rather elevate the pent ceiling to a higher level. Some have suggested that this elevation might have been intended to avoid interference with the masonry of the Grand Gallery, although this theory is debatable. The complexity of this design, involving large quantities of heavy granite, contrasts with simpler designs seen in other pyramids, such as the Mihdam pyramid. In Mihdam, the lower chambers are spanned with flat limestone beams, and the upper chamber uses corbelling. A similar straightforward solution could have been applied above the King's Chamber flat roof, but instead, the Great Pyramid features a more elaborate structure. It has been proposed that the 5 spaces above the King's Chamber might hold symbolic significance, connected to the 5 equal courses forming the walls of the King's Chamber. The extensive use of granite is notable, not only in the ceiling beams but also in the side walls supporting these beams. However, the availability of granite seems to diminish as higher chambers tend to have walls constructed from limestone. Archaeologist Petrie reported cracked beams and signs of movement in the construction. The limestone supporting blocks along the north and south sides showed cracks and flaking due to top pressure. The end walls, between which the chambers stand, exhibited sinking, as indicated by plaster ledges that originally fit into the edges of the ceiling. Petrie documented numerous construction lines in red and black, with the black lines appearing more refined and conforming to whole cubits. While much attention is given to the Khufu hieroglyphs today, Additional data on construction lines and clearer images of these spaces would provide valuable insights into their purpose and construction. Thank you for following along on this exciting journey into the secrets of the Great Pyramid of Khufu. We hope you enjoyed exploring the hidden rooms and passages in this magnificent architectural marvel. The history of this pyramid aligns with the roots of Egyptian civilization, but the mysteries surrounding it continue to pique our curiosity and inspire us to keep searching. With each new discovery, we gain a deeper understanding of the incredible engineering skills and meticulous planning that went into building this colossal structure. Scientists and archaeologists are committed to continuing their research to uncover more buried secrets within the corridors and chambers, enhancing our understanding of ancient Egyptian culture. If you're interested in more exploration and ancient history adventures, feel free to subscribe to the channel and hit the notification bell for updates. Share your thoughts and ideas in the comment section, and don't hesitate to ask any questions you may have. Once again, thank you for tuning in, and we look forward to your participation in more of our future journeys into the depths of our history and culture. Until the next video, anticipating new and thrilling adventures together.